Buttery smooth, 3D printed. I'm in a safe place. Whew. Buttery smooth, 3D printing time lapses. Today on Mikey's Lab. Hey, and welcome back to the lab. If you haven't already, go ahead and hit that subscribe button down below to ensure you stay up to date with all the latest content coming from the lab. Now, 3D printing time lapses are nothing new. Most of the time people use Octoprint. I'm probably the only person in the world who's going to tell you this, but I hate Octoprint. I have had absolutely nothing but problems with Octoprint, and as an engineer, putting another point of failure in the 3D printing process seems foolish to me. It is really hard to get a time-lapse dialed in with Octoprint, so I'm going to show you how to free yourself from stupid webcams with low resolution and a Raspberry Pi with software that's not necessarily working 100% the way that you think it should. This will require some small hardware modifications and a little bit of software that I will provide you for free, and you can modify all you want. So, when we talk about time lapses and 3D printing, these two seem like they should go together quite well, and they do. You talk about how a 3D print goes, and it's layer on top of layer on top of layer on top of layer on top of layer of melted plastic being put down. So the theory being that if you take a picture of the 3D print after every layer, you'll be able to create a beautiful smooth time lapse. Now there's a couple of vectors or traps for new players when it comes to this. First, the only way that the time lapse really looks any good is if the 3D print head is in the same place for every picture. And this is where Octolapse tends to fail, at least for me. I know other people have said that they've had great success with it, but it fails horribly for me. So, the way that I've been able to create time-lapse videos like has been with this, okay? The first piece is an external trigger for my DSLR, okay? So what this means is when I got this, it originally had a 16-inch phono jack on here, which had two rings and the tip. What I quickly discovered with a pair of alligator clips is that if you short the two rings to the tip, the camera takes a picture. All right. So what we're going to do in that case is we're going to take one of the old micro switches that came from my Creality Ender 3. Let's see if I can get my camera to focus. Right, when I installed the BL Touch. This is the old Z-axis homing switch. I attached an extension lead to that, and then I just made a JST connection so that these two can be taken apart. So what's going to happen is we're going to set the camera up in photo mode, right, at the highest resolution that this camera can take, which is about 5,000 by 3,000 pixels. And at the end of every layer, it's going to take a picture instead of capturing a frame of video from a web camera. Now, what this is going to give us is a time-lapse video with a resolution of 5,000 by 3,000 plus that we can pan inside and put artificial motion into in order to make awesome, buttery smooth time lapses. Now, there's a couple other things that you need to be aware of when you're going to do the time lapse. You need to control the light around the 3D printer because most of these prints are going to go 12, 14 hours, so ambient light can change. So what I tend to do, and you'll see when we go over to the 3D printer, I put a piece of foam core beside the printer facing the window to stop light from outside changing the light profile on the 3D print. The other thing that I do is I use a tripod that's independent of the table the 3D printer is on. I found the motion that the 3D printer puts into the table caused really weird effects in the video, so it needs to be as independent as possible. Now I understand that this still exists. So the idea is that this needs to be slack so that the motion that the 3D printer puts in doesn't come through. The other magic that's being done is via software, and it's a program that I wrote, and it will be on the Mikey's Lab GitHub, which I will link down below. You can download it, you can download the source code, you can take a look at it, you can change it however you want. It accomplishes several things. The first thing that it does is it finds the layer breaks, and it parks the print head in a specific spot. Now, there are two stages. There's a pre-park and a park. The pre-park brings the head back to almost pressing this button, which is screwed into the V-slot extrusion on the printer, right? So it's almost pushing, and then it goes ahead and it pushes the button, and it comes off, and then it goes back to printing again. That small step is a big difference between how Octoprint's implementation would have done something similar to this and getting it right, I guess. It tends to be a lot less jerky. The print's not moving when it hits the button. That pause is beautiful. The other goal that the software helped me accomplish, my camera prior to about 2 weeks ago ran on battery power. Now, 14-hour print, if you've worked with DSLRs, you know the battery's not going to last that long. So it gives you the option to set in a number of layers before you want the break between, or to pause, and allow you to change the camera's battery. Now, I went ahead and created wall power modification for the camera. It's a Sony A5100. If you guys want to see how to build that, I'll be more than happy to make the video. Let me know in the comments down below so that I don't have to worry about battery switching, because that often put in movement in the camera. And when the camera shut off, when it came back up, you'd have to refocus and you'd have to adjust the zoom again. And getting those 100% was a pain, and it wasn't consistent. So it being able to shoot right through is much better than how it used to work. So basically, as I said, what we're doing at the end of every layer print, we're putting the head to the back right, we're bringing the print all the way forward, we're taking a really high-res picture, and then we're continuing to print. Well, we're checking to see if it's battery swap time. And if it is, then we pause. If it isn't, then we continue to print. After the first layer, another piece that made this a little bit better, and it's code that's in the program already, you don't have to worry about it, is that after the first layer, the printer will pause with the first layer printed ejected out for you to focus and frame the camera. A lot of the other ones I saw, like Great Scott, did a very similar thing, but he wound up guessing where the print would be and what the focus would be, and I didn't want to guess. So it's going to print the first layer, it's going to spit that out, it's going to park that head, and it's going to wait for you to press the button on the 3D printer. And in that meantime, what you are going to do at that moment is you are going to attach the sensor, and you are going to focus the camera. Once those are done, you're good to go. So, without further ado, let's jump over to the computer. We'll take a look at the source code of the program and how it works. I'll take you through setting up a model. Then we'll jump over to the printer. I'll show you how I set up the entire rig to take a time lapse. Then I'm going to take about a 14-hour break. Then we're going to come back here, take a look at the time lapse, take a look at the print, and see how it all worked out. Alright, so here we are in Cura with the model that I'm going to print loaded. As you may have figured out by now if you're watching the second video, I'm using this for 2 videos. So it's kind of a mesh skull, the idea being that I can throw an LED light in here and it will have interesting effects of light on the wall. The print settings from Cura may affect the filament test that I'm doing, but it's definitely not going to affect the time lapse. We are printing with 0% infill, right? Simply because there's just so little places where there would be infill in this that there's no point. We're printing at 60 millimeters per second, and I'm using a layer height of 0.2, so fairly standard. I'm going to continue with my normal PLA profile here and have the nozzle be at 210 degrees and the bed be at 60. So we're going to go ahead and we're just going to slice this right now. Wow, this is taking a long time to slice. It's almost like it's a really complicated model. Okay, so now we're just going to save to file. Normally when you do 3D print, you would save directly to the SD card, but we have another processing step to do here. I'm going to make my life a little easier. I'm going to go to this PC, and drive C. I'm going to go to users, trusted one, source code, repos, and add. Okay, and we're just going to throw it into the release folder where the executable is. Okay, the other thing I'm going to do to make my life a little easier is I'm going to grab the file name from here. And we'll click Save. Alright, so now we're going to come over to this window here. Alright, and the program's name is Add Time Lapse to G-Code. Alright, and I'm going to go ahead and bring a lot of the options forward from the dev environment just because it's easier and I can explain. Okay, so first parameter is the G-code file name in. Okay, so in this case it's ./ce3 underscore skull .g-code. Next parameter is going to be the output, which again is going to be in this just going to dump it to this folder, and we're going to call it skull timelapse.g-code. Next parameter I'm going to specify is the wait at the beginning for us to focus. I'm going to specify that when we go to do take a picture, that we're going to retract 10 millimeters. All right, and then once we're done the retraction, I'm going to specify that we purge 10 millimeters, which is going to put the filament back in. -S is, give me 1 second, I believe that's just the delay time, how long we wait. -S is shutter weight. So this is how long we're giving the camera to take the picture before we assume that the picture's been taken and move on. I use 500 milliseconds, so about half a second. And we say X at 220 and Y at 235. Now what these are is the park locations. So this is where we're going to put the print head when we want to take a picture. Okay? So I'm going to go ahead and click run to that, and what it's going to do is it's going to go through the G-code. It's going to do a lot of math based off of movements to figure out retraction, how to put the timeline to put the pictures in. We'll take a look at the source code in a second. If you want to skip the source code, I will put a time code in the description down below to jump ahead to the actual taking of the time lapse. And it's done. We see that there's 398 layers in this print, which means we're going to have 398 pictures. Now the amount of space that takes is all dependent on how much detail and resolution your camera has. Alright, so now what we can do, I'm going to take this, bring this down here. This is just the source code for the tiny application. So basically what we're doing here, the program runs, we go into main. I haven't filled out the usage yet. I will before I upload it to the GitHub. We have wait for focus variable, which is do we want to pause after the first layer to wait for somebody to focus the camera. This allows you to have the ability to, through the flags down here, the -W or -wait that you saw in the previous step, to tell it to wait for focus or not to wait for focus. So if you're doing your 4th time lapse of the day, you know that the camera is in the right position, you know that the focus is there, and you just want to be able to walk away, you can obviously modify the parameters of this program so that it doesn't wait. We have global variables for retraction and prime. I put these in because I found that there was some horrible stringing when you didn't retract a substantial amount of filament before the move to park the head. Okay, the E and E offset are just us keeping track of the extrusion level. Because the variable is being modified by us, we need to make sure that we are consistently updating that as we have changed it throughout the rest of the print. Because if you modify the G-code extrusion level at, let's say, line 10, at line 50, it still assumes that it was the same as before. So once you've modified it at line 10, you must continue to modify that G-code all the way through. We have global variables to store the current position. We have global variables to store the park XY values, which the default is 210 and 235. I generally use 220 and 235. We have a global variable that acts as a flag to be whether or not we have battery swaps involved. This actually turns into, instead of 0 and 1, 0 and or the number of layers you want to print before a battery swap. Default shutter weight is 750 milliseconds. I've reduced it to 500. Again, I'm trying to find efficiencies to make this go faster. So the first thing we do is we go through the command line and we parse all of the arguments out. So we check to make sure that the file that we said was coming in exists. If not, we just abort the process. We say the file's not found and we exit the program. If it is, we go through all of the optional ones that I talked about, whether it's the weight, the retraction, the prime, the battery swap, the shutter weight, park X, park Y, right? And the default will be print help, which again I have not implemented in this version, but I will by the time I've uploaded it. And then we open up the file, okay? And we start going through line by line of the G-code file. First thing we make sure is that the line starts with G, because if it doesn't, we don't care. Right? If it doesn't start with G, we just write that line back out and continue on with life. So we break the line up based off of, is there a semicolon? Right? If there's a semicolon, then we take the substring prior to the semicolon. And then if that's 0, then we just ignore it. We split based off of a space character to take the remaining values and put them into an array. And then what we're doing here is we're looking at the first character in each of the arrays. So, or each of the values. So if the first character of the line was an F, right, we're going to parse out the value. We're going to store it back to our global F for now. If it starts with X, right, we're going to parse out the value. We're going to store it to global X. We're also going to look to see if it's higher than the print volume, apparently. Okay, so what this line here does that I just changed, in case you didn't notice, is if the current X is outside of the range of what we call the park value, so in this case 220, so if the X position in G-code has gone to 225, let's say, we basically say stop at 220 because I don't want you to smash into the micro switch, miss steps, and wreck the print. Okay? I don't do this with Y because Y, the maximum I put in is the maximum of the bed itself, but it would not hurt, so just to make it a little more resilient for everybody else in case you use a different position for your micro switch. Okay, and then we check the Z, where we are in the Z, and store that back through. And then we look at the extruder. If the value equals E0, then the G-code itself has reset the value for the extruder's output. So we reset both our E and our E offset variables to keep everything in line with each other. All right. So at this point, what we do is we turn around and we rebuild the G-code command. And we write that back out to the G-code, to the main G-code itself. Now, if this particular line starts with layer, right, that means that this is a layer start. Okay, so what we want to do at this point is we want to do the magic of inputting the new G-code, making things happen so that this goes through. So first thing we're doing is we're setting E offset to be the retraction. So we're telling the G-code in the next line to retract by 10. So we write G1, E, and then the retraction, and then F1800 for the speed at which we want to retract. The next thing we do is we send the print head to the pre-park location, which is the same as the park for Y and park X minus 10. This means that we're going to do this. Okay, so we're going to pre-park the head. We're going to pause for 250 milliseconds, right, which is enough to stop any vibration that is in the 3D printer at that point. Then we're going to move X to park X and Y to park Y, and we're going to park the print head, which is going to hit the micro switch, which is going to tell the camera to take a picture. Right, we're going to issue an M400 command and wait for all the moves to finish before we start doing anything again. Okay, so here's where some of the magic happens too. Basically, if this is the first layer and we have set the flag to wait for focus, we do an M0 command, which puts the text on the LCD screen of the printer saying focus camera, and click to continue. This is going to also give us the opportunity to attach the micro switch, focus the camera, frame the shot, get everything the way that we want before we press the button and things go. Once we press the button, right, it's going to jet back out and go back in and hit that micro switch to take the actual first layer picture. The next one is if this is a battery swap layer. Right? If it's a battery swap layer, we're going to pre-park the head, right, not hitting the micro switch. Right, so we're going to stop at X minus 10 and park Y, and we're going to put the message swap camera battery on the LCD. Okay, and we're going to wait. Once those two are done, or if neither of those apply, we're going to enter a shutter wait, which is basically wait for 500 milliseconds with the command line parameters I used, or 750 by default, to wait for the camera to take the picture. At that point, we're going to do the move back to where the XY location that it was at the start of the picture taking process, and we're going to prime the nozzle back to put the filament back in. Right? And then again, this is the other part of that. If it doesn't start with G, we don't care about the line. We just write the line back out. Then the program finishes, and you get another G code file. So if we look over here and we go back to that folder, alright, so here we are at my trusty Ender 3. You can see I've already gotten the tripod out and ready to be set up. So there's a few kind of traps for new players when it comes to creating these beautiful time lapses. I currently have the printer starting to heat up to do the filament change to the new blue filament. Alright, so I mentioned before that controlling the light is very important when it comes to time lapses that are going to take hours upon hours to work with. So what I have is I have a couple of these clamps that will clamp onto part of the tripod and allow me to hold the light on the tripod. So first thing I need to do is grab my light and grab my clamp. And this is going to be very hard to do one-handed, but I will figure it out for you guys. Alright, so then, okay, so we have the light attached directly to the tripod now, and as you can see, I plugged into wall power because batteries hate me and I hate batteries most of the time. So that's going to shine light directly onto the front of the build plate where our skull is going to be built. So give me a second, I'm going to go grab the camera. Alright, so at this point we have the DSLR mounted on top of the tripod, looking over top of the light, shooting directly at the build plate where this is going to go. I have a secondary video camera that I always set up while this is going on so that I have B-roll that I can intersplice in between two. And I have a 1080p webcam shooting top down from the bed. This is the level of cameras that I use to get interesting angles for you guys. Hope you appreciate it. And you can see my power cord bodge to simulate a battery hanging out the bottom of that camera. And it will always think that it has 60% battery at this point. Okay, so as you can see, the first layer is done now. I am actually thoroughly impressed with the build surface of the Overture build platform that came with this filament. I don't know if it's just a reaction between their particular filament and this particular build plate, or if all PLA will stick this way. But yeah, it's really stuck down there. I'm hoping when it cools it comes off a little easier. If we look at the LCD screen, you can see that it's saying focus camera, and then click the wheel to continue. Now, because my auto bed level, which as you can see had a little bit of a malfunction during the actual printing, I've never had to take a part off my printer in the middle of a print before, but apparently I lost a couple of the nuts and it was kind of dragging, so I saved that. And it is now currently off. Alright, so now when it's doing the auto bed level, I have a 16-point check for the auto bed level, and it goes to 235 on the X axis. So if you have the sensor in place prior to this, it's going to ram into that, and then that's going to cause it to lose steps, and yeah, it just doesn't sound good. So I don't put the shutter switch in place until now. So okay, so that's nice and firmly in there with that button being pressed with the machine there. I like to give it a few seconds now so that the timestamps on the pictures can be very specific as to when the time lapse happened. I also take this time to route the cable for the shutter out of the way of everything else, and then we go ahead and we hit the button after we make sure that everything was focused. I'm assuming that the layers, especially in the beginning here, are going to be fairly quick. Alright, so we're going to let that print. This is going to take about 11 hours. I'm going to come back. I'll give you my final thoughts over on the bench after we take a look at the time lapse, and we'll go from there. See you in a bit, guys. Alright, so obviously it's the next day. You now have 380, I think, some odd images on your SD card, and you're sitting there and you're going, so where's my time lapse? Well, that stuff is kind of up to you. Personally, I like to use Premiere Pro. I import it as an image sequence. It turns it into a movie clip, and then I can edit it. I can add glitches to it. I can reverse it midstream. I can do all kinds of interesting things to make it, well, more interesting. But essentially that is how you create a super smooth 3D time lapse without using Octoprint, without using Octolapse, and the results, well, they kind of speak for themselves. Me and this guy are going to chill for a little bit, probably get to know each other a little better. I'm going to try, I think, to find a way to put an LED in here so that it functions as a light and puts an interesting pattern onto the ceiling when it's lit. I think that'd be kind of neat. But either way, I want to thank you for joining me in the lab. I hope you learned something today, and we'll speak again soon.